All right. Section 1.6 is all about the absolute value. All right. So the absolute value of a number is its distance from zero on the number line. Okay. Distance is always positive or zero. So the absolute value is always positive or zero. Okay. So we need to think of distance, right? So let's just say that we have the absolute value of x equals 4. Okay. And let's say I draw this number line. And here's 0. Here's 4. Here's -4. All right. And I am at 0. So I'm going to draw. Don't judge me on my drawing skills. Here's me on 0. And I'm going to travel a distance of 4. Well, I can either go this way, 1, 2, 3, 4, or I can go this way. Both ways I traveled, I went a distance of 4. Okay. Distance is always positive. It doesn't make any sense for you to say, oh, I went -4 ways to the left. I just went 4 ways. It just happened to be to the left. I still went a distance of 4. So that's why when we talk about absolute value, it's its distance from 0. Okay, so that's why it's kind of difficult to think about because we're thinking of distance, and distance is always positive because it really doesn't make any sense for it to be negative. So that's why we can say that the absolute value is equal to 4. We can say that x equals 4, or it can equal -4 because both of those, 4 and -4, we traveled a distance of 4 like we did on our number line. Okay. So let's just say if C is a positive real number and X represents an algebraic expression. Okay, so C is a positive real number, X, okay, capital X, represents an algebraic expression. Then the absolute value of that algebraic expression equals a positive number is equivalent to X equals C or X equals -C. Okay, so it can equal the positive or it can equal the negative. Okay, so say we have something like this, and I say solve the equation. All right, we have the absolute value of an algebraic expression, 2x minus 1, is equal to a positive real number. Okay, that means, according to the thing that we just read above, that 2x minus 1 can equal 13, or 2x minus 1 equals -13. All right, so we can solve both of these equations, right? We know how to do that. And we get 2x equals 14. We divide by 2, and x equals 7. Over here, we have add 1 to both sides, and we have 2x equals -12. We can divide by 2, and x equals -6. So our answer, we will have 2, we will have -6, and 7. Okay. So your thing to remember with absolute values is that because it's the distance, we're saying that the absolute value of this, so the distance of this equals 13, we can either go in the positive or the other direction. Okay, so we're going to set it equal to the positive. Okay, this stays the same. 2x minus 1 stays the same. Your algebraic expression does not change. This is the same. The only thing that changes is this guy. Okay, 13 and -13. You solve both of them separately, and whatever you get is your answer. Okay. Now, let's look at some radical equations. Okay. What do I mean by radical equations? Well, it would not take you very long to figure out that this means that they're just equations with a radical in them. All right. And we're going to solve these by 4 steps. We're going to isolate the radical. So that means we're going to have a radical and then everything else on the other side. Then you're going to square both sides, solve by factoring, and then check it. Okay, so let's isolate the radical. Means that you have your radical on one side, everything else on the other. So we're good. We have isolated it. Then we're going to square both sides. So we have the square root of x minus 3 squared equals x minus 5 squared. Okay. Once again, we're getting rid of our radicals. So we're going to square it. Just like when we get rid of our squares, we take the square root. Okay. So they're inverses of one another, just like multiplication and division. Okay. If we want to undo multiplication, we divide. If we want to undo division, we multiply. If we want to undo a radical, we square it. If we want to undo a square, we take the root. Okay. So when we do that, we're just left with x minus 3 on this side, okay, because that got rid of our radical. And then we're saying x minus 5 times x minus 5. All right. So when we FOIL that, we're going to get x squared minus 5x plus 25. All I did was FOIL that. So we have some like terms on the other side, right? So we have x minus 3 equals x squared minus 10x plus 25. And then we need to solve by factoring, okay? We're at this step. If we want to solve it by factoring, it needs to be in standard form. It needs to be equal to 0. So I'm going to subtract x from both sides. And I'm going to add 3 to both sides. And I'm going to do it all at the same time. If you need to do it in different steps, that's fine. But this gives us 0, and also this gives us 0. So we're left with 0 equals x squared minus 11x plus 28. Now we're going to factor the right side. It's an easy trinomial. Both of the signs are the same, and they're both negative. And we need the factors of 28 that are going to add to give us 11, which are 7 and 4. Okay, it's equal to 0. So now we're going to take, we're going to take both sets and equal them to 0. We're going to add 7. So x equals 7. We're going to add 4. And we're going to get x equals 4. Okay, so x equals 7, x equals 4 are the numbers that we got, right? But now we're going to need to check them, okay? We need to check them and see if I actually get something that's true, okay? So we can do our check right here. Here's our check. So we got x equals 7. So we have the square root of x minus 3. So we're going to say 7 minus 3 equals 7 minus 5. So we get the square root of 4 equals 2. And the square root of 4 is 2 equals 2. 2 does in fact equal 2. So this is true. All right. So our x equals 7 works. Now let's check x equals 4. Okay, let's plug in 4. So we get 4 minus 3, the square root of 4 minus 3 equals 4 minus 5. So we get the square root of 1 is equal to negative 1. The square root of 1 is 1. 1 is not equal to negative 1. So this is false. Okay, so our only answer, so this was false. Our only answer is x equals 7. Okay? X equals 7. So this was a radical equation. We squared both sides, moved everything over, put it in standard form. We got something that we could factor. We set both of our sets of parentheses equal to 0, and we solved. And then we checked to make sure that we actually got something that was true and not false. Okay. All right, so let's do this one. 2x plus 15, the square root of x, 2x plus 15 equals x plus 6. So we're going to square both sides because our radical is isolated. Equals x plus 6 squared. When we squared that radical, it got rid of our radical sign. So we just have 2x plus 15 equals, and we did x plus 6 times x plus 6. And we get x squared plus 6x plus 6x plus 36. So we can clean that up a bit and get x squared plus 12x plus 36. And then we need to factor this, but we need to get it in standard form. So we're going to subtract 2x and subtract 15. All right, so that gives us 0 equals x squared plus 10x plus 21. So let's factor this guy. It's an easy trinomial. X and x, our signs are the same and they're both positive. So the factors of 21 that add to give us 10 are 7 and 3. And then we have x plus 7 equals 0. X plus 3 equals 0. We subtract 7 from both sides. Subtract 3 from both sides and get x equals -7. X equals -3. Okay, now we need to check them and make sure that they're actually true. Okay, so check is we get the square root of 2 times -7 plus 15 equals -7 plus 6. Okay, so we get the square root of -14 plus 15 is 1 equals -1. 1 does not equal -1. So this is false. So x equals -7 is not true. So let's check the other one. The square root of 2 times -3 plus 15 equals -3. -3 plus 6. So we get, here is -6 plus 15 gives us 9 equals 3. And the square root of 9 is 3. 3 does in fact equal 3. So our only answer is x equals -3. And this is our only answer. Okay. So a good giveaway that you are going to have to square both sides in radical expressions is if, number one, you have a radical expression, which is this guy. All right. But your directions also say solve and check. Okay. These are the only ones where checking was not an option. Okay. We have to check these because you're going to have one that's not an answer. Okay. Like in these two examples. Okay. 4 was not an answer and -7 was not an answer.